Welcome to section 2.5 for Math 31. We're going to cover the subject order of operations. Now, to make some sense of that title, we have operations like plus, minus, times, and divide, exponents, and so forth. And you have to do them in a prescribed order if you're going to get the right answer. It would be totally chaotic if we didn't have these rules. So you have to learn the rules if you expect to get the correct problems or correct answers. Okay, so we're going to start here on example A, which is a simple exponent. And what's important to know on this first example here is that because of the parentheses, the base is a negative number. That negative is also part of what's being taken to the fourth power. So because the parentheses includes the negative sign, that means that negative sign is going to be multiplied all the way down. So now let's see what we get here when we complete this. Negative 3 times negative 3 gives 9. 9 times negative 3 gives negative 27. And finally, negative 27 times negative 3 is 81. You see my calculations off to the side over there. Okay, on the next one, it's different. The negative sign is not encased in a parentheses. So what this means is that the negative sign is not part of what's being affected by that power. So you're just going to say 2 times 2 times 2 times 2, and the negative sign just stays on its own outside. All right, so now let's do the calculations. Negative 2 times 2 is negative 4. Negative 4 times 2 is negative 8. And negative 8 times 2 is negative 16. Okay, on the next one, we have a subtraction and we have a multiplication. And in this case, multiplication is higher priority than subtraction. So the subtraction has to wait. You can see I just copied it. Meantime, 4 times negative 5 is negative 20. All right, so then we're going to switch to subtraction, and you change that to adding the opposite. So you get 18 plus 20, and that in turn gives 38. On example D, we have a multiplication here. We have a subtraction that's inside parentheses there, and we have an exponent on top of that. Normally the subtraction would have to wait till the very end, but because it's inside the parentheses, they look like square brackets in this case, it gets done first. So 16 minus 12 is 4. And now we do the squaring before the multiplying. 4 squared is 4 times 4, which is 16. And you can see the calculations off to the side there. Negative 5 times 16 is negative 80. Okay, on example E, we have a mixture of wide variety, actually, of operations. There's an addition, an exponent, a division, and a subtraction. Normally, the add and subtract would be done last, but because they're both inside grouping symbols, in one case, the addition, it's inside these parentheses. And in the other case, the subtraction is inside the absolute value bars. Those are both grouping symbols. So the add and subtract are done first. Negative 8 plus 5 is negative 3. And 2 minus 5 is also negative 3. All right, now we do the exponents and we do the absolute value bars. We do those both before the division. And if you take negative 3 times itself, you get 9. Negative 3 times negative 3 is 9. And the absolute value of negative 3, in other words, the positive version of negative 3, is just 3. So now we just take 9 divided by 3, and that gives our final answer. Okay, on example F, we have a set of parentheses inside of another set of parentheses. And that's where you start, is the innermost part of it. So you're going to take care of all the parentheses first, but start on the innermost pair. 8 minus 6 is 2. Exponents get done next. That exponent gets done next, so that gives 9. And now the multiplication gets done, and that gives 4. And then 9 minus 4 is 5, and now the parentheses are all gone. We do multiplication next, 20. 20 plus 15 is 35. So you can see, maybe I should highlight this, but most of this stuff just copies from line to line to line to line. In other words, you're gonna write down everything you're not working on. An example of that is between this line here and this line here, the only change I made was right there. Everything else just copied. And that's good mathematics, is to put all your stuff down. I don't want you skipping stuff, so put all the symbols on every line. All right, example G. The difference here is that we're given an expression and we're supposed to plug in some given values. We're going to be plugging in, let's see here, we're going to plug in -6 for the x and 8 for the y. So it says 3 times the x, you can see I wrote 3 times -6, and -2 times the y value, and the y we're putting in 8. All right, so the next thing we got to do here is figure out the order of the operations. We're going to be multiplying before subtracting. So -18 and 16 are the next thing we do. And then we subtract, and you can do that by adding the opposite. So -18 plus 16, you can see the calculations off to the side where I added over here, and that gives 34. -34 when you take the negatives into account. Okay, another example of this, a little more complicated here. What we have here is a y value of 2. So I'll put a 2 there. You can see that right there. And then an x value of -3. So where it says x, you're going to put a -3. And then where it says z, you're going to put a -4. And it tells you it's -4 up there. So now that we have it written out, we have to decide what's the highest priority. Addition, multiplication, subtraction, multiplication, and an exponent. Exponents are higher priority than all of them. So that back part there is what you do first. And I'll do that off to the side. -4 times -4 times -4. This would be 16 times -4, and that's -64. Okay, so that's the only change I made from line 1 to line 2. Now we've got a mixture of adding, subtracting, and multiplying. Well, multiplying is higher priority than over the adding and subtracting, so we're going to do the multiplying. That gives -6, and 5 times -64, you can see some calculations off to the side, gives -320. All right, I see subtracting, so I'm going to change that to adding the opposite. And then the next priority here is the adding and subtracting in order. So you add those two and get -4, and then you add these two and you get 316. So that's our final answer. Okay, on example I, the goal here is to find the average of some numbers. We're given 4 numbers here. And if you're averaging 4 numbers, you'll add them up and divide by 4. If you had 5 numbers, you'd add them up and divide by 5. So I wrote them in a different order. I want my positives up front, so that takes care of the 38 and 16. And they add up to 54. And the negatives I put in the back, and they add up to -38. You can see the over here the calculations. And then I've got opposite signs. I'm going to add those. When the signs are opposite, you actually subtract. So here you get 16, and 16 finally divided by 4 gives 4. So the average of those numbers is 4. Okay, we're going to look at 2 more problems here, and we've got this chart that tells us scores for 7 golf players. You can see, for instance, that Jake was 6 under par by the end of 9 holes, it says in the problem. So in golf, you want the lowest score possible. So Jake is actually the one that's winning, and Brian is 4 over par, which isn't real good. I'm sure he's better than me, but here we go. What is the difference between Brian's score and Bill's score? So we're supposed to subtract those in the order we're given. It doesn't turn it around. So Brian minus Bill. And in this case, you're going to add the opposite. So you get 9. There's a 9-stroke difference between Brian's score and Bill's score. Brian is 4 over par, which isn't as good as 5 under par for Bill. Okay, what is the average score for Bill, Andy, and Pat? Okay, Bill, Andy, and Pat. Bill, Andy, and Pat. We're going to be adding these 3 numbers up and dividing by 3, and you can see that's how I've set it up here. Add these numbers and divide by 3. Okay, the first 2 add up to -8. And when you add 2 more, you get -6. And finally, you'll divide by 3 here, and you get -2. Now, it's important to note before we move on here that if you've got a long division bar with a bunch of numbers added or subtracted up there, I just put letters instead of numbers, represent any number you want, then this is really like having a set of parentheses around here and a set of parentheses here. So in other words, you have to do all these calculations and all these calculations before you do the division. It makes the division very last in line. Okay, so that does it for section 2.5. And if I can encourage you, this section is one of the most important in this course. If you don't master order of operations, then you're really going to struggle with the rest of not only this course, but next courses. It's basic. It's fundamental to mathematics, this concept of operations having a specific prescribed order. So do a good job.